Okay, let's continue. Let's move on. The next I'm going to talk a little bit about is go-to statement. Okay, and this go-to is a keyword, and when you go to, we should have a label. And this label is identifier. Okay, which means you can give name to this label. And the main rule is we have introduced before is that we can use big data, small data, and numerical digit and underline. Okay, and you cannot start in by a numerical number. Okay, this is the rule for identifier. So go-to label is a statement which means go-to. Okay, it's very easy to understand. Go to where? Go to this label. Go to this label. And this label, let's take an example. So we use one function. Okay, I should say one function. Suppose you we have only seen one function called main. Okay, now if you go to somewhere in your program, you have a go-to statement. Go to ABC. Okay, and ABC is an identifier, a label. Okay, a label, and ABC you should show up somewhere in this function, in this main function, within this pair of big bracket, somewhere you should have a ABC and a column. Okay? It is important that you put a column here. Okay? And it means once you go to this statement and execute this go-to statement, the next step is the next function. Not function. The next statement will be executed is the statement after ABC. ABC is here. ABC is here. ABC is here. So go to ABC means go to here. And the next statement I'm going to execute is the right next statement after ABC. Okay. In today's programming concept or programming society, programming community, or we call it a good programmer, should not use go-to too often. In fact, there's only one occasion you can use go-to. Okay? Only one occasion you can use go-to. Because if you're using go-to too often, you use go-to to many go-to, you will see something like this. In here, we go to A. Now A is here. In here, we go to B. and B is here. And here we go to C, and C is here. In here we go to E, and E is here. Okay? So the program will look like that is you from here to A, go to here, and then go to B, go to here, and then go to C and go to here, and then go to E and go to here. What does this look like? It looks like spaghetti. Okay. What is spaghetti? Italian. Okay? So, this kind of Italian is difficult to anything funny. Okay? This kind of situation, this kind of go-to will make people very difficult to trace your program. Okay? We have no idea how is the logic of your program. How is your program is programming flow is going. Okay? So don't use go-to as the priority rule, except one condition. Okay? Except one condition. Now, I'm going to say under what condition you are allowed to use go-to. Okay? What's the condition? Before we say the example, last time we introduced an array called A. So this, once we have this, we have A0. The size is integer. And then we have A1, the size is integer. And so on. We have A9. Okay? So this 10 is size. But the actual index is starting from 0 to size minus 1, which in this case is 9. Okay? So this is 9. Now, we can have a multiple dimension array. We call this array. We call this integer array. Okay, because each element is an integer. But we can have a multiple dimension array. Or we can have a two-dimensional array. Suppose we have an integer b and a 3 and a 4. And you see this, we declare 3 times 4 is 12. We have 12 integers. In memory allocation, we will have a B00. Again, same as one-dimension array. Here, this is one dimension. Okay. And in here, we have a two-dimension array. In one-dimension array, the index start from 0, end at size minus 1. Similarly, in two-dimensional array, we also start from 0. Okay? And the size is also an integer. And then we have a B01. Okay? Integer. And we have a B02. Okay? Also integer. And the B03. Okay, we have an integer. So how many integers so far? 4. We have 4 integers. Do we have a B04? B04. The answer is no. Just like one-dimensional case, the last one is size minus 1. So 4 represents 0, 1, 2, 3, 4. Okay? So last one is 3. Last one is not 4. It's 3. Okay? So what you see here is 0, 0, 0, 1, 0, 2, 0, 3. Sorry, not 0, 4. The next one is what? The next one is B10. Okay? Let's continue here. And each has size of integer. So B1, okay? So now you put it. It's kind of spread out this two-dimensional thing into one dimension. Okay? So 1, 2, B1, 3. Okay, B2, 0. Okay, B2, 1. Okay? Until what? Until actually we are almost there. B2, 2. B2, 3. Okay? Do we have B3 something? B3, 0. The answer is no. Because, again, this 3 represent 0, 1, 2, and then no 3. Okay? In memory space is continuously allocate. This variable is continuously allocate. But conceptually, you should realize this two-dimensional thing is B00 and B01 and B02 and B03. Okay? And B10, B11, B12, B13, and B20, and B22, B22, okay? B23. Okay, so we have 3 rows here, and we have 4 columns here. So 3 times 4 is equal to 12. So totally we have a 12 integer. Now, all of these are integer variable. So, again, similar to one-dimensional array, you can do b, which b21 is equal to 10. Okay, this is legally written statement. You can do b3, or not 3, sorry, not 3. You can do b11 equal to b22 plus a0. Okay, where's a here? In the previous example, a0. Okay, here. A0. Okay, as long as it's integer variable, or you can multiply by b10. Okay, so just like regular integer variable. So we have 3 dimensions. How about we have 2 dimensions? How about 3 dimensions? Okay, we can have a double 3-dimensional array. C 3, 4, 5. So how many dimensions? 3 dimensions. And the first dimension, the index is 0 to 2. The second dimension is 0 to 3. The third dimension is 0 to 4. So totally, how many double variable here? How many double variable here? It's 3 times 4 times 5. So 60. And similarly, can we have a 4 dimension? Of course, character array. B with 5, with 10, with 15. Now, with, okay, with 12, with 3. So we have 4 dimension. How about 5-dimensional array? Of course, as many dimensions as you want. Again, too many dimensions will make you confused. You may forget what is the first dimension represent for. What is the second dimension? What is the third dimension? What is the fourth dimension? And what is the fifth dimension? That along 6th dimension, 7th dimension, 8th dimension, 9th dimension, 10th dimension. They are all legally can be used, but for a human being, for a regular programmer, I would say it will become very difficult for us to handle such many dimension array. Okay? Now, I'm going to introduce a doubling function called R, A, and B. Okay? It's a random, it stands for random number. Okay? What is random number? What's random number? Suppose you are rolling a die. Okay? 掷骰子. Okay? Suppose you are 掷骰子, not 掷骰子. The first time you got the number of 2. The second time you got a number of 3. The next time you got 1. And then the next time you got 4. The next one you got 2. The next one you got 5. The next one you got 3. The next one you got 6. The next one you got 1. The next one you got 4. 5. 4. 3. 2. 1. 4. Please tell me, do you see any pattern of this sequence of number? No. It's impossible for us to predict what's the next number. We might call this sequence of number. It's a sequence of random number. Just like you rolling a dice, okay? 好像在丢骰子 okay? Now, the computer can simulate, okay, such behavior by generating a random number. But this kind of random number is not between 1 and 6. 1, 2, 3, 4, 5, 6. It's the possible number coming out from rolling dice once. These are the 6 only possibility outcome by rolling a dice. But in computer, it will generate a sequence of random number by using a function called length. Okay? Now let's see this. Let's see that. Now, say we call this function. This function is, I think it's in this stdlib. Okay, it's a function prototype. It's a function name, and we will talk more about this in when we teach function. Okay. Now we will not do anything. We just random number. Okay. Okay, we call random number. Now this random number, how we get this random number? A random number is get from RAND, this function. Okay? Now we do nothing else in this after this function call. As I say, for rolling a dice, you only get 6 possible number, 6 possible value. But this function of length, which is a built-in library function, it will generate a number. The range is much bigger. We'll talk about it later. But we just print the number we get by calling this length function. So we just print this value. Okay? Just print the value. And print how many random numbers we print. 0.0, to 10. We print 10 random number, okay? Please look out. We're starting from 0 until I is not less than 10, okay? Which means we are going to print 10 random number by calling this random, right? Too bad is that we forgot to put backslash n to jump to next line, so it's difficult to read. Okay? Now, the first random number is 41. The next one is 18467. The following one is 6334. So how many random numbers? We have 10 random numbers here. Perhaps we like to say random number random number percentage D. Number one random number is equal to a random number. Okay? Now in here we print I. We certainly can starting from numbering the random number by let's say by starting from 0, but for normal person we usually starting counting number from 1, so we plus 1 here. Okay, because I is initialized to 0. Okay. Now, you see, number one random number is equal to 41. Number two random number is 18467. Okay? That's this kind of sequence number, similar to reloading a dice. The answer is not, because no matter how many times you run this program, this sequence of numbers are always, the first one is 41, the second one is 18467, until this one. Okay? And individually, okay? So it's not a really a random number, because each time when we call random, we always give you 41. Let's execute again. Okay? We always give you 41. Okay? So it cannot simulate an actual situation of rolling a dice. So what we can do is not like, is using calling another function called srand and put in an integer value. Okay, srand represents so-called seed. Okay, what seed mean is something that at the beginning, at the initialized state of the sequence of random number, just like rolling a dice. So the seed will determine the sequence of number, and by putting a new seed value, you will get different sequence of number. So we can write this. S1 will generate a second random number S2 and generate S3. In fact, in the internal computation formula, it using S1 to compute S2, using S2 to compute S3, using S3 to compute S4. Okay, maybe we should not use S. We should use maybe C1 will generate A1, will generate A2, and from A2 will generate A3, from A3 will generate A4, and dot dot dot. And if we starting with a different seed, we will generate a B1, a B2, a B3, a B4, dot dot dot. We generate a different sequence by changing the C value. Okay? Different C value will generate a different sequence of number. Now, let's go back where is my program? Where is my Visual Studio? Did I close it? Did I close it? You can always reopen it. Okay. No. We really don't know. Okay, so here. Okay. Now, we make a variable called seed, and we're going to get the seed, scan percentage D, and ampersand seed. Okay. Now, after we get the seed, we call sRun this built-in library function, and we put this seed. Okay. In fact, there's an internal variable hidden within the C compiler. After the compile of this program, there will be a hidden variable inside the sRun and the rand. Okay? And this variable will determine the sequence of the number. It just looks like a random, okay? But in fact, it's not random. It's dependent on the C value. So now, let's see the result. You might understand what I'm saying better. Okay? Now, maybe we could put a little message before. Print seed is equal to what? C equal to 1. And this is the sequence. It seems the same. Strange. 21. Okay? When we change the C into, let me enlarge the character from to 24, 28. Okay, so when we change the C into 21, we see this this sequence of random number. Okay? Execute again. If we change C into 31, we see this sequence of random number. This sequence are different, or is different from the previous one, or we set the C at 21. Okay? Now supposedly we execute again, we see set the C at 21 again. We see 107, 4064, and 4060. Now we execute again, 21. We see the same sequence. As long as you're using the same seed, you see the same sequence of random number. So actually, what we call a random number is not very random. Okay, it's not very random. It just looks like random. Okay, look like random. So we call it pseudo random number. In Chinese, we call it 虚拟. Okay? The concept of this pseudo-random number is very important for management or for economic study or even for transportation or communication, etc. Because when we do a simulation, a pseudo-random number is very, very important tool to use. But the only thing is, where is my Visual Studio? Okay. The only thing is, all the result is depends on the seed. Okay. So normally for many of you will play computer games, and each time you play the computer game, you generate different setting. Okay, and the random seed is probably using the time you started the game. Okay, maybe the second, hot day, hot hour, 1 minute per second to generate the setting of the game. So you play the game different time, you got different environment or setting. Okay. So this is random number. Okay. Let me say this program first, and let's continue after 10-minute break.